Assalamualaikum and good day everyone. So our group gonna present about the topic that we have learned last week 2, which is pre-stressing. So before we continue, I want to introduce our group members, which is Azim, AFIF, Amri, AQIL, and myself, which is FIRDAUS. So what is pre-stressing? Pre-stressing is a technique used to improve the concrete structure against cracking, but introduce a pre-compression forces to counter tensile stresses that undergo from the beam concrete. So what is pre-compressioning? Pre-compression is a condition of the concrete that results from the tensioning of the steel tendons. It enhances the beam's ability to resist loads and prevent cracking when it is subjected to tension from the applied loads. So there are two types of pre-compressioning. First is pre-tensioning and secondly is post-tensioning. For the pre-tensioning, the steel tendons are stretched before the concrete is poured. Once the concrete hardens, the tendons are released, transferring the stress to the concrete. As we can see from the diagram given, the tension is applied between an anchoring point. Then the concrete is bonded to the steel rebar strand. And lastly, the concrete reaches specific compressive strength, then the steel rebar strand is released. Next is the post-tensioning. The tendons are placed in ducts within the concrete and tensioned after the concrete is cured. From the diagram, we can see the concrete is cast around sleeve or ducts, and pre-tensioning steel rebar strands are threaded through them. You can see the hole there. In the hole, we put the sleeve or ducts, and after the concrete is cured, we put the pre-tension steel bar inside the hole. After that, after the concrete reach specific compressive strength and steel rebar strength are stretched using hydraulic jacks. So we can see the red one is the hydraulic jacks. Stretch the rebar steel strand. Then steel rebar strand are permanently anchored at each end. So we can see that when the steel strand is pre-stressed, concrete beam when steel strand is in a pre-stressed concrete beam are released, the beam usually bend upwards, right? Due to the steel strand itself. So in the process, once the concrete has hardened and the steel strands are released inside the concrete beam, the tension in the steel are transferred to the concrete itself. The release of the tension causes the steel to try to return to its original length. So as the steel contracts, it pulls the concrete along with it. This creates a compressive forces along the bottom of the beam that's supposedly to be in tension, right? Before, after the load applied. But because of the steel strength is released from its station, is give a compressive force at the bottom of the beam and a tensile force along the top. Since the bottom of the beam is under compression and the top is under tension, the beams is bent upward. So that's all for me. This next my member gonna explain the next slide. Thank you.
Here are the components of pre-stressed beams. Firstly, we have duct, anchorage, hydraulic jack, strand or tendon, grouting hose, and finally bursting link. Next, we have steps to install pre-stressed beam. For pre-tensioning, firstly, tensioning the steel. The tendons are pulled tight by applying a precise force using hydraulic jack. Then, pouring concrete. Once the steel is under tension, the concrete is poured into the form, covering the tendons completely, and finally releasing the steel. Once the concrete is strong enough, the tendons are carefully released, transferring their tension into the concrete. Then we have post-tensioning. For post-tensioning, firstly, concrete pouring. Once the ducts are in place, concrete is poured over them. Then, tendon insertion. Once the concrete is cured, the steel tendons are inserted into the ducts that were pre-installed in the concrete. After that, post-tensioning. Specialized hydraulic jacks are then used to pull and tension the tendons, creating the necessary force to compress the concrete. After that, anchoring the tendons. Once, once the tendons have been tensioned, they are anchored at the end. And finally, grouting the ducts. After the tendons are anchored, the ducts are filled with grout.
So next, why the pre-stressed concrete is preferred compared to conventional in situ construction method? So firstly, the structural strength and performance, which is the pre-stressed concrete, higher load capacity and reduce of deflection, while in situ method, it is lower load capacity and prone to the deflection. And next, the material efficiency. The pre-stressed concrete require less material for the same strength, while the in situ method is require more material for the strength. And next, for the cost, obviously the pre-stressed concrete less cost due to material and labor saving, while in situ method it is using higher cost due also due to material and labor savings. And lastly, for the others, which is the quality, obviously pre-stressed concrete more high quality than the in situ method. And for the flexibility, it is more innovative design. And for the in situ method, it is limited the shape and so on. And that's all.
So next is how coastal concrete construction can contribute toward SDG 9 and SDG 11. What is SDG 9? SDG 9 is innovation, industry, and infrastructure. How pre-stressed concrete is related to the SDG 9. It builds resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. So in the first picture, uh, it is a reinforced concrete that show the beam is cracked under both deck and service loads due to the tensile stress induced by bending. The cracks are controlled by the reinforcement within the beam. The second picture is partially prestressed concrete beam. The beam remains uncracked under dead load due to the compressive stress induced by prestressing. The beams crack under service load, but the cracks are smaller and less pronounced compared to the reinforced concrete beam. The pre-stressing force help to reduce the tensile stress. The last from the picture is fully pre-stressed concrete beam. The beam remains uncracked under both deck and service load. The high level of pre-stressing effectively contracts the tensile stress, preventing the formation of crack. So the picture on the right is show that we can save more space because pre-stressed concrete can be built smaller but more strength than in situ concrete method.
Next, how precise concrete construction can contribute toward SDG 11. SDG 11 is a sustainable city and community. As we know that precise concrete give a huge strength and resilience to the natural disaster. With that, the community or the people that live in the building or the structure will become more safer. This precise concrete will not make the building or the structure easily to collapse. This make the precise concrete achieve the SDG 11, which make the city and human settlement inclusive, safe, resilient, and sustainable.